Hello and welcome to MSE 402 Project Management. My name is Dale Deerdorf. I'm your facilitator, instructor, and coach for the sessions. And what we've got lined up for you in this course lecture for Module 3 is the planning phase. We're going to overlap this planning phase. You've done 2 phases ahead of this. The executing phase is coming up behind this. Now it's time to plan the project. So let's take a peek at how we do that. What does that look like? So from a PMI PMBOK perspective, they show this flow of time across one domain and the levels of process interaction that are required. And you can see that that planning process group falls out of the planning performance domain. So go ahead and grab your PMBOK, the new PMBOK, and go to page 51. And on page 51, you're going to see that planning performance domain. It's going to walk you through all of the components necessary, but ultimately we've taken all the scope that we knew and the project charter, and we've pulled it down into the point now where we're going to really start to put together a solid plan. We're going to integrate in the WBS. We're going to pull in all of these pieces, and what that looks like is going to ultimately be the flow that we've got for you in front here. So you can see that we've completed the introduction and initiating phases. We're now into that planning phase. We're going to start putting together a manual WBS that can then go off and be put into some level of project schedule. We're going to create an MS project WBS or alternate tools because you've got alternate options available to you, and ultimately that's going to create bar charts and a charting, a visual description of what's going on. Now at the same time we're flowing down into the procurement plan and the resource plan. Those are all the solid elements of the planning phase, but at the same time we're overlapping down into the risk matrix, the risk register, the communication plan, our solid budget, our control tools, and our KPIs. All of those theoretically are being planned at some level during this phase. Now, some of these may have already been planned. You know that you've covered some of the known risks ahead of time, so you've laid those out. But we formalize everything in this particular area, setting ourselves up for the next phase, which is going to be executing, followed by the monitoring and controlling phase, followed finally with the closing phase. So if we take a look at the planning phase, it actually composes the planning group processes, which consists of the processes performed to establish the total scope of effort, define and refine the objectives, and develop the course of action required to obtain those objectives. Now, the way that happens is what we refer to as the project planning phase. Okay, it begins when the project has been formally approved and funded and the project charter is approved. This phase requires study and analysis culminating in the full project management plan, and that may lead to the addition of system development activities. So acquisition activities are performed, and if necessary, to obtain contractor support, subcontractor support, consulting support, all of those come in, and the work is broken down into what we call specific tasks and subtasks, in addition to the milestones, the hard milestones that we need to have. Now, control documents related to this effort are produced because many times there's a hierarchical flow that says that you have to put out some level of documentation at this point before you can move on into executing. So depending on the formula, depending on how tailoring your organization is about how they set things up, specifically what we're going to be working on is the WBS structure by decomposing the scope statement down into that. That's specifically the area that we want to focus in on. Now, the planning phase ends with a formal review during which the adequacy of the project management plan is determined. So that project management plan basically it takes all of the elements that we've got, it controls all of them together, it capitalizes them into one area. So we've got a plan, how to execute it, what the elements are of it, what the pieces to it are for us to continue moving forward. So let's just talk about this project planning phase. It's where the project solution is further developed. That scope statement gets as much detail as possible, and the steps necessary to perform the project objectives are planned. Everything that needs to be done needs to be understood at this point, if possible. In this step, the team identifies not only all the work that's to be done, but the tasks and resources required. Anything that is required for us to have from a resource standpoint so that we can accomplish these tasks needs to not only be identified, but the feasibility of being able to use it needs to be made available. Once the project team has identified the work, prepared the schedule, and estimated the cost, the three fundamental components of the planning process are complete. That's what we needed to get to this point. This is also a good time to identify all project stakeholders and a plan describing the information needed and the delivery method to be used to keep the stakeholders informed of the progress, the project progress. Part of that may be in the communication plan, and you may at this point have a draft or have an informal communication plan that you are putting in place. In addition to that, it's time now to start working on what we call the WBS. It's a hierarchical plan that is also referred to as the work breakdown structure. It's a description of all the project work activities focused on the deliverables. So you will have a deliverable, and then in that WBS structure, you will see that there are the elements necessary to get your level down. So you can see in this particular description that we've got over in the graphic underneath me, there's a home construction, and that's level 1. Underneath level 1, there are 5 different areas. There are mobilization, foundation, structure, landscaping, and the project closeout. That's the second level down. Then, if you take a peek under just the structure element, that third element across in level 2, you now go into level 3, and you can see that under the structure we have the framing, the roof, the interior, and the exterior. All of those are level 3 tasks or subtasks built out from a hierarchical standpoint as we move down. And then finally, if you take that interior and you continue down from the interior into the plumbing, you can see that on level 4 we have, mechanical, electrical, plumbing, drywall, decor. All of that must happen. And all of that filters up. So you can see how that builds itself up. The WBS structure is that hierarchical structure that walks the plan level by level by level by level, task by task by task by task with subtasks. Okay? Now, to create a work breakdown structure, we want to start at the top and work our way down, from deliverables through more detailed work packages. The image that I have off to the side underneath my graphic actually is part of this Manchester downtown hotel project. Now, if you're looking at that graphic, you can see it's common practice to put the top level, and this was done in Microsoft Project. You can see the top level is done where it says Manchester Downtown Hotel Project. That is the level 1. The next level below it is acquire property. That is level 2. Level 3 is going to be hire a realtor. The next one down in level 3 is going to be find suitable property. And then inside level 3, 3-1 would be research commercial activities. 3-2 would be interview potential candidates. 3-3 would be select realtor to work. You can see how the subtasks flow out of the regular tasks. So each subsequent major deliverable that is part of the main one will be listed underneath and indented. So there should be a component indentation for every major deliverable. This is the structure that we create when we're putting together the work breakdown structure in Microsoft Project or a software package of some sort. Now, once we jump into that, for each of the major deliverables, you can see that the project team will need to identify the necessary components for creating, supporting of those work packages. And you start to find smaller and smaller pieces until you reach the work level where work is assignable, to where you can actually put someone's name down on it. So you can see that in the image off to the side, hire a realtor. These 3 tasks, researching commercial realtors in the area, interviewing potential candidates, and selecting a realtor to work with, are all subtasks of hire a realtor. And then find suitable property has 3 of them also. So this is the work breakdown structure, and this is typically the level we go down to. We don't typically go another level below that if necessary, but you could. You can see that you may need to blow some of these out and create subtasks on subtasks, depending on the level of detail required. Now remember, activities are at the level where the actual steps to complete the project exist. Work packages, remember those, are comprised of all of the steps required to complete a specific deliverable. So in that WBS structure, you had a work package, and then if you unpack that work package, you had tasks, subtasks, elements, and you could theoretically have a start and finish milestone hidden inside there. But stylistically, they are also indented one space further out from their given work package. Within Microsoft Project, they are generally set farther apart because it has a default to kind of indent a certain number of spaces, and it may, depending on what you're working with, be a bolded or an italics type of indent that gets put in there. Now, there are certainly more, there's more work required to develop a hotel than the steps listed above, but this is an example of the sample for creating a simple work breakdown structure. Your projects are going to be more in line with what we've got listed here. So you can see that you have a manual WBS template that we provide you, and in that template you can see that I've gone ahead and given you these different levels. You can see that you've got at least the start, which is your project. You're going to define that. You would put that in the top line. And then below that, you have work packages. So you have the feasibility study. That's a work package. You have the next one, the next one, the next one. All 5 of those on top are work packages. Then below that structure, in the test area, you've got 2 down there that are work packages. All of those are required. All of those we gave you and told you that you have to have as a minimum those 7 work package levels in your WBS. You can add anything you want in those 3 blank ones. You don't have to use the 3 blank ones, but they are there to show you and illustrate for you how to create the next level of structure if you want, because you may find that in your project there's other steps, other major work packages that you think are necessary. You can see below each work package there's another indication number-wise of what you would want to add as far as tasks go. So you identify the major tasks underneath that work package, and then inside each task you can have subtasks. Over here on the bicycle example that we've got, you can see how easy it is to identify the bicycle, and then underneath the bicycle we jump into level 2. Under that, we then start to put the frame set, the crank set, the wheels, the braking system, the shifting system, the integration, the project management. All of those could be considered work packages. And then underneath that also, as you come off of 1-1, the frame set, and you go over to the frame set, the tasks or the elements below that would be the frame, the handlebar, the fork, the seat. All of those are components umbrellaed away from that. This is just an initial draft structure for the WBS. It prepares you to be able to then translate that into one of the other tools that are available for you. Whether you're going to do that manually into a manual tool, whether you're going to do that into a software package, that WBS structure is going to get integrated over for you to be able to see exactly what it looks like as you get ready to put together a formal Gantt chart and a formal schedule. Okay, so let's talk about this. In the figure to the left that I've got set up here, you'll be able to see how a sample MS project work breakdown structure would lay itself out. The structure's already been developed and linked with project hierarchical structures for predecessor and successor logic for each major task and subtask. This view that you're seeing here also provides you with the ability to see both the start and stop dates for each task, and the WBS forms what we refer to as the backbone of all the planning project activities. It divides the scope of the project into smaller manageable work packages for maintaining better control of the project objectives. Now, as you move from the higher levels of the WBS to the lower levels, the definition of the project gets more and more detailed, with the upper levels representing the major phases of the project it is imperative to remember that the WBS represents 100% of all the work defined in the project scope. You should be able to take your project scope and decompose each statement. Each line of that should be pointed down into the WBS structure, and you should be able to draw a line and say, that is accomplished here, that's accomplished here, this is accomplished here. That would be a requirements traceability type of activity, and that's how you do that, okay? Anything that is not included in the WBS is not considered part of the baseline initial scope for the project, okay? Now, in addition to that, once you're into a tool like Microsoft Project or some of the other software packages that are out there, you can toggle over into something that is referred to as the network view. The network view is a tool used for schedule planning and monitoring work completion progress while the project is in progress. So the network and the schedule for the project are developed using the work elements within that work breakdown structure. It then takes those elements and puts them into a graphical flow diagram of the project's job plan. It gives you the ability to see the entire project mapped out in that format. And the project network shows all the project activities that still need to be completed in order, for you to have a good, clear understanding of what's going on. You can see theoretically the critical path, and you can see what you've accomplished up to a certain point. So that project network also gives you a good, clear understanding of the interdependency of the work activities and how long each should be completed. Now, one example of a great, I'll call it advantage of a project network is anytime you have two elements that come together on a project and those two network nodes connect together into another subset, okay, that network joining, I'll call it interface. Whatever that work activity is at that point in time is going to be something that as a project manager, you need to watch as closely as possible, because what happens almost always is that there's some level of conflict anytime these two network pieces come together into that next one. Both of these must happen for this to start or for this to happen. And if one of these elements structurally cannot happen on time, it stops the entire flow. So, lessons learned from a project manager standpoint, always look for choke points. Those two coming together is referred to as a choke point from a project standpoint. And those are the areas where we want to make sure that you watch, observe, make sure that you've got good communication, that you've worked any of the issues associated with that area, because those will stop your project dead. Now, from this, you're going to be able to determine the critical project start and stop times also. You can start to see lag and lead times. You'll start to see where you have opportunities to potentially fast track something, or where you have problems that you know are going to slow your process and your project up. Let's talk about these nodes also. So node analysis, or activities and networks, within this node analysis, they're used to illustrate project activities in these networks. These are represented with arrows and boxes, and each node can represent a work activity depending on how you want to lay it out. Now, networks will help you schedule your project schedule by helping to identify the dependencies and the sequence of the activities and the times that, where they're going to overlap. The work breakdown structure is not designed for this, but this network diagram, this node analysis, gives you the ability to see that. The schedule won't give you that visibility to it. You have to go into something that's referred to as a network diagram to really see this type of overlap, this type of constraining activities. Now make sure you add dependencies, the sequences, and other timing of elements into your schedule, into your plan, because that helps you complete the network and the project schedule to a point where it is a usable tool. Now, let's talk about this network node diagramming and illustration. So this is referred to, I'm going to walk you through 3 different elements so you can see in the project flow that we've got set up off to the side. You start in the start box, you finish in the finish box, and there are 3 paths through this project. In the illustration I have, path 1 would be blocks A, C, D. You start, you go to A, C, D, and then you finish. The second flow through this diagram is going to be the start, and then you go to B, up to C, D, and then you finish. And then finally, the third path through the project is going to be start, and then you go to B, and then you go to E, F, and you finish. So you can see in this simple illustration, there are 3 different paths through this program or this project. Now, let's talk about precedence diagram methoding, PDM. This is a diagramming technique for network schedules wherein activities are shown as nodes. Similar to what we've shown here, the schedule activities are linked graphically with logical relationships to illustrate the sequence in which the activities are to be performed. The next terminology, the next thing is called precedence relationship. This is the term that it's taken from the precedence diagramming. It's a method which illustrates the logical relationships. Within this module, the term logical relationship, precedence relationship, and dependency are all used interchangeably. They mean the same thing. And then when we talk about predecessor activity, this term indicates a scheduled activity that will determine when the logical successor activity can begin or end. You have predecessor and you have successor logic. The two of those together give you the flow and what's important. So the next piece we want to talk about is called the critical path. Those of you that are using Microsoft Project, it will plot the critical path for you automatically. The critical path is only the longest path of activities through the project within the network diagram. That's all it is. It isn't something bad, it isn't something good, it is the longest path. Now, the reason that people think that it's bad is because any hit to the critical path extends or delays your project. So a one-day hit somewhere on an activity that's on the critical path will lengthen the project. So the longest path is the minimum amount of work that would be necessary to complete all of the project work. And remember, delay of any work activity on the critical path would delay completion of the project. So if we look at the graphic we have aside from us here, you can see that from a duration standpoint and from how we've got it set up from a flow standpoint, that middle path is the critical path. It's got a red line through it. A, B, C, D, E is the critical path in this particular network diagram. Okay? That can be determined based upon slack, based upon what's happening to you, your early start, early finish, your baseline start, baseline finish dates give you the ability to plot and understand exactly where a project is at any point in time. Now, when we talk about slack or float, it's a term that relates to the work activities that are not on the critical path. Anything not on the critical path is called slack or float. Therefore, any one of those tasks could be delayed without impacting the completion of the project because it doesn't impact the critical path. Slack is something that you really need to know. Where do I have slack in my project? Because it's useful for shifting the start of work activities, especially if you've got limited resources. If you've got an opportunity where I can pull something in, fast track it, and run it to eliminate some of my slack, but I get something completed, that is a formula for success for a project manager. Remember, these resources could be specialists, tools, locations, it's anything. Getting something delivered early from a procurement standpoint might offer you the opportunity to work some activities ahead or out of order, but in a path that gets you through the project faster. So remember, by delaying the start of an activity, you could inadvertently increase the length of the working time for the entire project or an activity. Remember that. Now, let's talk about schedule compression. What does that mean? And schedule compression is one thing that businesses can value when a project isn't just completed on time, but when the project is completed before the scheduled end date. There may be a contract line item that says that any time you can deliver, say a week early or 2 weeks early or 3 weeks early, there's an incentive that may make it worth the wait of trying to go ahead and get a schedule completed early. If there's no impact for overrunning it, maybe it makes sense to outweigh the cost overrun, the schedule overrun. So you need to be able to look at schedule compression. There's instances when a business would rather have a project completed under budget, but not completed within the original time. Think about that. So we save money, but we deliver late. That is a real world type of situation. And many times you need to understand, is that what we have an opportunity to do? Does that make sense? Now, there's one way to reduce the expected time remaining on the period, and that is shortening the critical path. If you can shorten the critical path, the time required on all non-critical paths, we will not see any tangible benefits on the project duration. But if you can take anything that's on the critical path and compress it and find a way to get it done ahead of time, your schedule will shorten. Now, there's three elements we want to talk about. Fast tracking, I've kind of alluded to. Scope reduction is another piece. And then finally, worst comes to worst, we have what is probably the most destructive to your project schedule and to your project costs, which are called crashing. So let's talk about fast tracking. By fast tracking, you're arranging tasks on the critical path in a parallel form. They can be completed or worked on concurrently. These activities on the path are connected by predecessors. They will set the order in which these critical activities will be accomplished. That's called fast tracking. Scope reduction means that we look at our project scope and we say, what do we maybe not need to do? What can we prevent needing to be completed by either relaxing a requirement or looking at the critical path and saying, is this really something that should be done? Could it be done in another time, in another place? Could we shift it? Something like that can be done. Scope reduction is a method. It should never be pursued without the express permission of the customer and any and all stakeholders. And it's the last resort, since it'll require removing or modifying an already agreed upon project scope. Your project scope needs to then be reworded, lined out, changed, modified. Now, when we crash a project, what does that mean? Crashing a project means that I decide that we are going to take every resource we have available to us, I don't care what it is, and we're going to throw it on this project, and we are going to complete this project, whatever it takes. Now that means you may have people that have skill sets that aren't the ones that are complementary for what needs to be done on the project, but we're going to use them to do that. Everybody jumps on board and everything is done. All these new resources are added to try to shorten the tasks on the critical path. It is one of the most destructive things to a project. And the reason I say that is every time you do that, it will always increase the cost of the project. Your budget will go nuts when you're crashing it. You may come in on schedule, but you will overrun the budget. Now, there's different types of predecessors in this logic that we talk about. There's external, internal, mandatory, and discretionary. So let's talk about these predecessors. An external predecessor is placed within your project by external entities. An example would be waiting for permits before a construction activity could start, or the best realtor being out of town for a week. Those are external predecessors that could prevent you from starting something on time, and these are predecessors that you want to make sure you line up. Now, an internal one is a predecessor that comes from within the project, and they can also arise and cause you problems. They are within the control of the project team. An example of this would be if one shared resources was required for two different projects, and the teams were limited in how they used it since they were sharing it, okay? The next one is going to be a mandatory predecessor. A mandatory predecessor cannot be fast-tracked since they must be done in a specific order. Placing the roof on the house before you've put up any walls or laid any foundation would make it impossible to complete the house. There are certain things that must be done at certain points in time. Those are called mandatory. And then the final piece is called discretionary. A discretionary predecessor is there simply because someone on the team wants it there. Always be aware of discretionary predecessors when attempting to fast track a project. Whenever we fast track a project, it'll always increase the risk. So don't forget that. Now, Dr. Goldrath had a book he wrote on TOC, the theory of constraints. Very good. We're going to walk through that in other lectures. We're going to talk about that in some of our threaded discussions. But the 5 steps essential from a theory of constraints, Goldrath formula are identifying the system's constraints, number 1. Exploit the system's constraints. Subordinate everything else to the exploration of the decision. Elevate the constraints and then repeat the above steps. Every day you look at the critical path, you look at everything that's set up in the flow and you say, what can we do today to eliminate any of the constraints so that production can continue moving along in any way necessary? Goldrath's formula for the theory of constraints is one that's used by many, many aerospace companies, a lot of the big engineering firms, things like that. It gives them the opportunity to put things on a critical path with multiple projects running at the same time. And that way they can walk in and say, this is the one we need to work on. And everybody shifts over and works on that. And those are the 5 steps for making that happen. Now, Edward Deming talked about, variation. So did Shin Taguchi. I mean, the loss function that he created kind of alluded to it too, but there are 2 causes for variation in a system, according to Edward Deming. The first one is called common cause variation. Those are potential flaws in the system development. And then there are special cause variations, special cause or conditions, such as a worker or a machine error. Now, these variances can cause delays in your project activities in several ways. They can occur when the duration is not properly estimated. If I take and tell you that something's going to take a week, but it's actually going to take a month, I have already baked into the plan something that the project manager is going to run into and have a problem with. That's why when you're putting scope together, it is so important when laying that out and the initial schedule to be very accurate with your estimates. If you're not, what happens is it may seem that the overestimated project durations cause us to have these issues. Sometimes people will do something called padding their time. They know something's going to take a week, but they tell people it's going to take a month. That's the opposite of what we were talking about before. That puts us in a position where we've artificially created a schedule and a process that is not accurate. It is one of those systems that people do intuitively in an attempt to try to prevent, if somebody's going to cut time out of my process, I'm going to overestimate it so that I have the ability to try to pull back on that. Well, that theory of constraints, that critical chain process of walking through everything, focuses on the project constraints as a means to reduce those 2 types of issues, the variations in a project. You want to try to minimize that or eliminate those. Now, let's just for a minute talk about resources and what resources are. The resources that are available for you to use within a project are finite. There's 2 throttles you have: effectiveness and efficiency, based on cost, schedule, and resources. And those are the only things that you can really work within to try to make your project work faster. So remember that there will be a need to have decisions made regarding which projects are going to be given those essential resources. And it may not be your project. And that means that you, as a project manager, may run into, because you've done nothing wrong, unexpected delays or projects terminated due to a lack of resources. In this instance, resources can refer to professional tools, materials, or working capital. So remember that. The schedule or scheduling of resources refers to assigning the correct resources in the WBS. So if you look at the WBS and you say, these are the people that are going to work here, that's the way we resource load into that. We create resource loaded schedules. That gives us the ability to really understand how many hours we're going to need, by who, and if we've got any problems that may come up. By scheduling the usage properly, you can effectively utilize the priority of projects in a way that will prevent them from being jeopardized. And the consequences of poorly scheduling resources is that there will be additional costly work activity and project delays. Those will be natural to your projects. Now, in our project for ECS, we gave you a preliminary budget. We gave that to you up front and said, this is what the budget is. In addition to that, on a weekly basis, you may be running into situations where that budget is being eroded by additional scope coming in, requests for different things to happen, testing failures, overruns as far as things being closable on the project. All of those are natural. And I need you to understand that there are other things that can happen, like pay rates, overhead costs, rental costs, the expense of contractors. All of those are things that you may not have thought about at the time that initial budget was put together, but those are things that can take your initial budget and cause it to be incomplete as far as being accurate, which means that you could have an overrun, even though you ran your project perfectly, just because pay hikes happened, overhead costs went up, the cost of renting something changed. So those type of activities will create an individual budget for each activity that will encompass all of the associated costs. We want to make sure that these costs are added with the other associated costs into the work breakdown structure. Make sure that WBS covers everything you can think of when we're talking about budget. This creates a budget for each work package. We then add the costs of all the other work packages in order to create the project's budget. Unfortunately, in your situation, you were given a budget up front. You didn't get a chance to decompose the WBS to understand how far off or how close it is to that. So that's the difference you're going to see, especially when you start putting your schedule together. Once you create that baseline view, you then will create another view. That other view is going to show what all the additional tasks are going to be, and you'll find out whether you're up or down on your budget depending on what the addition of all those are. So let's jump into some of the estimating methods. So let's talk about these first three. Bottoms up. Bottoms up is typically going to be the most costly possible because you take every task and you basically say, what would that cost? Okay, add all of that up and you get a bottoms up number. That would be like taking a car and starting with the screws and say, how much would that one screw cost? How much would that screw cost? How would that screw that goes into a hinge, goes into a door jamb, into a door. Adding it that way is called bottoms up. You decompose the project by talking about all of the tasks bottoms up. Top down is another way, and this is typically done in what I'm going to call a formula where you kind of do a little bit of both. Top down would be, I just tell you, similar to what you got for ECS. You've got a budget of $250,000, okay? That is your budget. That's top down. I didn't tell you that I parsed it. Spend this here, this here, this here, this here, this here, this here. You have to do that, but a top down would break that down into each one of those work packages. And then you have 1 point. And this type of estimation is simple. It's an assertion. It's done based on past projects. The last time we did this, say the last time we tested a mega driver, it cost this. That estimate can then be used and articulated into future work packages. If that estimation was accurate, you're spot on. You should be really, really close. But if it was very inaccurate and that the knowledge used wasn't valuable, then you could have, in a 1 point estimate, a situation where things could come back to haunt you. So make sure you understand those three methods. Then we're going to talk about the next three. A 3 point, which is the one I like the best. That means we take the optimistic cost, the pessimistic cost, plus the most likely in a formula, and we integrate that together to get a 3 point estimate. That 3 point estimate takes into accompanying failures, successes, and everything. So As you can see over here, the 3-point estimate, the optimistic was 38, the pessimistic was 57, the most likely was 45. You can see what the integration of that in that formula that we've laid out here would give you 45.83 being the 3-point result. It gives you a number that's based on success and failure and looking at what has happened in the past, the most likely. Now, the next one you can use is parametric. Now, this estimate is used for a metric from past projects to determine an estimate for the current one. For example, say in your last project it took 12 days to build 7 rooms and cost $30,000. The current project requires you to build 14 rooms, so all we're going to do is we're going to double that. So the project should be given $60,000 and 24 days, which would be, the doubling of that, to complete. Not always going to work great, but it is one method for going ahead and estimating. Now you'll notice that, the number of days, even though we're doubling 12 to 24, sometimes when you're working in a parametric, you can take and you can have what's called a learning curve. The learning curve gives you the ability to say, well, as we continue doing this, we get faster and faster at it. So you may be able to, in certain situations, apply in a parametric position a learning curve which would reduce that cost for the additional secondary, third, fourth type of projects that come in behind that first one. The next and the final one here is the heuristic. This form is an estimate because there is no norm. I've told you to come up with a solution to anti-gravity. The project manager is going to estimate parts of the project based on what they've been previously. If it took a week to do one thing, that's how long it should take to do that. If it takes a week to get a drawing released, typically it's going to take a week for all the other drawings. With the exception of, let's say, okay, a systems drawing that's an assembly drawing takes 3 times as long. Using that logic, that's the heuristic form for how you put that together. Now, in closing, what I want you to do is know that project planning refers to everything you do to set the project up for success. It's the process you go through to establish the steps required to define your project objectives. And clarifying the scope of what needs to be done and developing the task list to do it is what we call the project plan. The activities in the project planning are varied because you have to work out how to achieve your goals. You need to use everybody on the project and know that every project is going to be different as the objectives will be different. Each project is unique in its own way, and most of the work of planning is thinking about what you need to do, get everything done, and put the structure in place to make that happen. How can we succeed? That last line as a project manager is what you need to write down. You need to get the right people at the right place at the right time doing the right thing and be as effective and efficient as possible, and you will succeed. That's my lecture for this week. I hope you enjoyed it. If you've got any problems, if you've got any challenges, if you've got any questions, feel free to reach out to contact me. Have a great week. Bye-bye.